Hello everyone and welcome to today's TRUMPF webinar on TruTops Boost with the exciting subject of preparation of 2D data. So this half-hour webinar focuses on the current workflow for DXF file preparation. Our cutting customers receive often parts in very diverse formats, such as IGES, DXF, STEP, DWG, Parasolid, and so on. But the problem with all of these models from so many different systems is that it is simply impossible to manufacture with them. Using a few examples, you find out how TruTops Boost offers every innovative sheet metal processor all of the programming tools that he needs to work quickly and efficiently, and in so doing enables him to get the job done cheaply. So we're going to go ahead and get started. For listeners checking out TruTops Boost for the first time, you might be wondering what TruTops Boost is. How is it different from our previous programming system and other products which are out there? And that's exactly my goal of today's webinar, to show you our revolutionary new software and its immense added value through increased productivity. As you can see here, TruTops Boost is divided into two zones, into two levels, the so-called home zone, which is basically our control level containing all the orders which we manage, and you basically get with one click on the boost button to the automatic calculation and therefore to your in-C program. The second level is the tech zone containing all the technologies and our new 3D CAD system. So you can modify and interactively modify all the automatically prepared programs and do any changes either to your geometry or to your technical solutions. And behind that, of course, is the new Boost technology containing all the automatic processing and all the new software architecture. Just briefly, for the workflow, we first of all import geometry. Out of every geometry, the program Boost creates an order which you attribute, and you add the part quantity and the customer information and many other attributes. And after that, third step would be creation of the unfolding if it's a 3D part. And fourth step, programming work step, would be the parallel automatic creation of the bending program and of the cutting program. And the fifth step would be, of course, releasing the NC to the machine transfer folder. So what should you look for in a 3D system? Of course, the simplicity in 2D, short learning curve, ability to process 2D legacy data, quick part and assembly modeling, associative 2D, 3D detailing concept, a flexible 3D import-export options, and of course the technological consistency through the whole system without any breaks and interruptions within your workflow. So for the data preparation of 2D data, first of all, it's quite useful to activate a import dialog which will be appearing if every time you open a DXF file interactively. Of course, you can switch it off after you have set your standard settings, default settings, but in case you will want to change them, you can either do it in the dialog, within the dialog, or within the options panel in the design level. So the adaptation of importing options. First of all, of course, you are still familiar with the automatic contour preparation. And for example, if you want to treat colors automatically and extract the geometry, you can use that automatic preparation. But of course, we have improved the whole import of 2D data. That's why we have implemented, for example, part thickening to a certain preset thickness, sheet metal thickness. But of course, you can switch on and off the automatisms, and that would basically, if you switched off, load the whole drawing sheet with all your dimensions, the drawing frame, etc. Well, for my topics today, I would like to present you four major categories and basically go from simple to more complex topics, and that would contain pure cutting part with interfering contours, such as, for example, sinkholes or dimensions or anything other else. Then third topic would be the import of 2D unfolding, which is there as DXF, meaning that we have to implement or insert bending lines, and of course with the correspondent deduction, the right deduction values. And the fourth topic would be importing of 3D bending parts, which are also there as DXF, meaning that there is a front view, side view, and top view. All right, let's get started. First of all, original DXF drawing, and my first topic would be pure cutting parts. So what do we have to consider if we work with DXFs which are just have to be cutted without any bending lines and so on? We have to be careful on the scaling, and therefore we need to check the scale, whether it's 1:2 or 1:5 and so on. Of course, we have to be careful with open geometry contours. But again, within the home zone, within our managing control level, Boost warns us if there are any open geometry, you get always a warning. If there is a problem, you get a warning. So the status concept, which is there, is very, very helpful and shows you in detail where the origin of your problem is. All right, then of course if there are threaded holes, we have to be careful, and I'll show you how we handle that in Boost. And of course we need to answer the question whether it's a 2D or 3D drawing. If it's a 3D drawing, we have to take in consideration whether we have to insert bending lines or correct the deduction values. You see here the user interface of the home zone. You're familiar with the division. On the left side we have our categories and some filters. In the center it's a list of our orders, and on the right side a detailed view of selected orders or nestings or single parts. So first of all, we're going to import some DXF and DWGs, and I'll just select them all and import via a batch import. And just to mention, on the right side you see all the supported 2D and 3D formats, and as you can see here in 2D sheet metal, it's of course our geo, IGES or MI files. Other than that, there are 3D files and direct formats which we all support. Those are basically all the major CAD formats. So if I open up the parts, I can of course filter to a certain name. I just add a finish date to all the selected orders. I add a quantity and a customer. All right, there are some warnings. I will get to that warning later on. First of all, I'd like to assign a material information. So my customer ordered all those parts as stainless steel in 1 mm. And of course, there's no bending machine, so I just deselect it and boost all those files. So there's no frame, there are no dimensions, there is nothing. So my customer is clever enough to send me the prepared parts which don't need any preparation. So I just import them and I'm ready to go. The next step would be the creation of the nesting. So I click on create nesting, and now I'd like to show you the warning which we had. Therefore, I just click on the order and I get back to my part. So we of course check within Boost whether a certain part is exists already or not, because we don't want you of course to have double work and to prepare geometry. If it exists, for example, if another colleague has made the job already, you always see it actually. And of course, what we have here is the same part you see within it within the dimensions and the surface, and it's basically compared to the with the technological data and not according to the name. So, but I want to use my drawing, that's why I click on ignore warning and go back to my job, and as you can see, my order list is complete now without any warnings. So I just select the machine, technology profile or table is selected according to my favorite settings, and I just select the raw sheet format and boost my nesting or sheet program. And right now in the background, my nesting profile is applied, the sheet gets nested, and technology is applied, and the C code with the setup plan is generated. Of course, there might be some very small parts where roundings are too small. We just get a warning, but we can ignore it. So total scrap is 55% because of part distance is 10 mm, and the parts are quite small, so that's a reasonable value. And processing time is there, recurrences of the sheet, and I just release it. So we are done with that example. I go back to my order and I just filter for the warnings. What I'd like to do is just to present you by numbers the examples. So 2 would be my second example, containing cutting parts with interfering contours. So again, we should take care in the scale, open geometry, contours, and so on. That would be another example with interruptions or breaks, breakthroughs, or any other symbols or threaded holes. We go into the system and check it there. So first of all, I would suggest that we create again a finish date. Quantity would be okay, metalware as our customer, and we set the material for all the example files I have selected. And again, I deselect my bending machine and boost my drawing sheets or the files. So I haven't selected the thickness because it differs, of course, and I need to check the drawing sheet or my file. So that's why I basically go from 1 to 4 and show you how we treat the different problems.
So as you can see, there are quite a few interfering contours. So I just switch off the automatic contour preparation and also the automatic part thickening, and just click OK. So you can see there are a few things to be checked. As we said before, 520 millimeters. So we just check the scale. I just hence measure the lines. So 50 should be that line. That's right. And maybe last check 30 mm. All right, we don't have the measurement for that, but 70 mm. So the scale is all right. The part thickness is 15 mm. So that's actually everything I need to know. And you see there's threaded hole. And but what we do is, as you can see, the part is in purple and or magenta. I just would like to prepare the geometry by selecting the color, pressing Control, and just deselecting everything else except my geometry, and press Control C and Control V. So within the structure tree, it's quite easy to see what I have imported. I'll just switch off my 2D import, and I see my copied geometry. And if you switch it on and off, you see that the dimensions are equal to the original drawing. So I just delete the imported drawing sheet. As in the next step, I just press F for fill the part, and we remember if we use spool and the thickness was 15 mm, I type it in, press enter, and delete the surface and the curve. And I convert the solid into a sheet metal part, validate everything, and you see that 15 mm is applied, and I just close the part and it's being saved back into the home zone. Well, design is alright. I can proceed to the nesting with that part. Alright, next example, quite similar. I just switch off the, again, part thickening and, alright, save it as standard. And what we see is that the drawing was again imported, and what we do is again checking the part thickness, and we just copy the things that we need. So again, I delete the original import and press F, pull the surface to 10 mm, and delete the surface and the curve, and convert my part, validate, and close everything. And again, I'm done. And the design is alright. And let's see the next example. So contour preparation, as you can see, now the contour is recognized, and I can even try to thicken the part. I just hit OK, and we see what happens. Alright, the part was recognized, and of course, as you can see, the data is gone now. If you want to check what's on the sheet, would be better to import the original file without preparation. But of course, as you probably have the drawing sheet before you in the paper form, you can easily check that. But I delete again all the unnecessary information. After we have cleaned up the geometry, it's also might be sometimes good to check where the origin is. And as you can see, it's a little bit off. And in order to correct it, we just hit move, we hit on the either component or the solid and click the corresponding arrow and say, okay, hit the ruler and the two directions. So from X, so it should be in both cases 0. So we have moved it now into the center of our part, but of course you can choose any other position. So if you hit move, select the whole component you'd like to change the origin on, and then select your 3 dimensions and move it accordingly. Alright, we are finished with that part. We have corrected the size, the scale, and even the position of the origin. So last example of the interfering contour. As you can see, part preparation doesn't help much, and of course to thicken the part won't help either. But we just open it and we can see again. We check the height, so it would be 5 mm, and there's a sinkhole, 2 of them, and even in the center. So of course we need the inner circle of all the parts or all the holes. So what we do is we need the original size. So 795. Of course, if you have the drawing, you have to check. Let's say it's 1000 mm. So what we do again, in order to clean it up, we select our geometry. Again, box select from the right. So we don't need those contours. We don't need the outer contour. Here the same. So that's why I deselected. And again, press Control C and Control V. And so what we do next is, if I measure, for example, the distance between those points is 30 mm. There is a quite handy tool within the Repair tab or 2D Technology or 2D Processing. So curve gaps. As you can see, if we type in, for example, a maximum distance of 0.1 mm, there would be a few points. So let's double click. It might be very small gaps in the curve. So we can do it either one by one or just hit the check mark. Alright, but if we increase the maximum size, let's say to 30 mm, because we have measured it. Alright, we have said that the whole part should be 1000 mm, but before that I just thicken up to 3 millimeters. So I just pull, delete the surface and the curves, go to sheet metal, convert the whole part, convert. Alright, in order to extend that part to 1000 mm, I just hit move, select my right side, we move it to the right side. From that center point, and that would be 1000 minus 25 minus 25, and that would be 950 obviously. And we also move those holes so from that center point again, and basically it would be 500 minus 25 because of that left radius. And again, those 3 holes are moved now, and we are ready. We validate the geometry, close it, and are finished. All right, so as you can see, we have treated the second example, so 4 parts with interfering contours, and you saw the different examples. So if I select my third example, there are a few parts, and again, I can use an existing example or just ignore the warning. I just click on use the part, and for the other ones, the same. All right, they are already in the system because I have imported them before. And again, I can batch, ignore warning, or just use the file. Just select one example, but basically it's every time the same. We can prepare, thicken the part automatically, prepare the contour automatically, check whether there are blocks or not, and click on OK. And you see it helps a lot actually to use the automatic preparation, because now the last step within my preparation, it's a basically it's a it was a 2D bending part, right? So deduction values have been applied. We just don't know which ones, and because we don't know the tools which have been used for that. But I know that that part is 1 mm. That's why I choose the tool radius, and the die width would be, let's say, 6 mm. And you see out of the database, the bend allowance and deduction is drawn. And the last step would be just applying all the settings, and you see that the part has been prepared. So it should be all right. Let's say after validating the part, there are no errors and no warnings, and we can now calculate the bending program. But basically what you do, if you have inserted the bending lines, just check for your dimension, because you see we've got now the outer dimension of 96.6 mm, and maybe it should be 97 or even 100. That's why you have basically to get your original drawing and create your original dimensions. And for that, you just again pull one side, choosing the ruler tool, set it to the opposite side, outer face, and type in your right dimension. So the part is now being corrected. Of course, you have to take into consideration maybe other contours, but let's say that was the only change I had to make. And in the last step, I would just save the part. Again, the unfolding is now created in the background, and I'm good to go for the automatic bend part calculation. But that will be done within the home zone. Right now I'm preparing the DXF, so the design, and everything else is done automatically within the home zone. All right, and let's get to my last example. I just ignore the warning, I do it again. So I select my customer, select the finish date, let's say 1 week later. I assign my material information, deselect the bending machine, and well, for the thickness, I'm not sure what thickness it will be, but I'll see it, of course, out of the drawing. As you can see, that's a 3D part consisting of three views of the part. So the top view, side view, and the front view. And what we do is we don't prepare the contour. We check, yeah, there are some dimensions saved within the block information. So if I import it, I see my dimensions, and again, I can easily check whether the scaling is alright. So 125, 125, and for example 40. So that should be alright. I check whether, no, it's not saved in a layer. But again, what I do is I select for the color and just deselect everything else I don't need. I copy everything. I delete the original one, and I'm left with the three views of the part. So again, what we do is we fill, and basically what we do is we interrupt or suspend sheet metal functions because we just want to create a 3D part out of it. So what I do is I use the tool guide that pulling to both sides, and what I do is I just create a solid out of my original drawing. That face I move by 90 degrees in order to pull it again into my existing solid on the left side. But what I do is if I pull it without selecting no merge, it would merge both solids, what I don't want at the moment. I select no merge and create another solid which just intersects the first one. All right. Basically, that view I don't really need, but we'll leave it for now. But what you can see, we have now two solids, one surface, and few curves, and we have a very, very handy tool called Combine. And if we hit that, we don't want to keep cutter, but what I do is basically I select the solid which I'd like to cut, and that would be my original one, the big one, and I select the other solids I don't need, and they are just being deleted, and I'm left with the part I need in 3D. So as you have seen, it's very, very easy to convert a bending part which is there in 3 views. At the last step, I would just convert the whole sheet metal part, and as you can see, the radius is not fitting, but what I do is again I just hit the mouse button and the right radius is applied according to my thickness, and in the last step again I validate, and within the validation my tools are being set, and you see my upper and lower tool are set now, and I'm good to go for that part as well. So we've seen in that webinar how easy it is to prepare DXFs, and I have skipped a few examples, but basically they are all the same. We have prepared around 50 parts, and we have created sheet layouts, and we have even converted a 3D bending part out of a DXF. And to sum it up, TruTops Boost works as expected. Sketch on parts and pull or move to adjust the part. There are no CAD restriction and rebuild problems such as in other CAD systems or programs. TruTops Boost works with any CAD geometry. There are no problems with CAD incompatibility, and the job is done faster than ever before. Don't hesitate to write feedback to us. Just email in, and just in preview for the next webinar topic, it will be text zone design and the fastest way from solid to the unfold. And if you have any ideas, please write us, give us feedback, and I'm looking forward for the next webinar and wish you a good day. Goodbye.